In this video, I'm continuing to describe the basic features of TypeScript and JavaScript that are required for Angular development and briefly touch on the RxJS package, which is used extensively by Angular and is required for some advanced features. In this chapter, we are using the primer project that we created in chapter 4. No changes are required for this chapter. Just open a new command prompt, navigate to the primer folder, and run this command. After an initial build process, the Angular tools will open a browser window and display the content as shown here. This chapter continues to use the browser's JavaScript console. You can open F12 to open the browser's developers tool and switch to the console, and you will see the following results. When the browser receives JavaScript code, it executes the statements it contains in the order in which they have been defined. In common with most languages, JavaScript allows statements to be grouped into a function, which won't be executed until a statement that invokes the function is executed. Functions are defined with the function keyword and are given a name. If a function defines parameters, then TypeScript requires type annotations, which are used to enforce consistency in the use of the function. The function in the example is named writeValue, and it defines a parameter that will accept a string or null values. The statement inside of the function is not executed until the browser reaches a statement that invokes the function. The code here produces the following output in the browser's JavaScript console. By default, TypeScript will allow functions to be invoked only when the number of arguments matches the number of parameters the function defines. This may seem obvious if you are used to other mainstream languages, but a function can be called with any number of arguments in pure JavaScript, regardless of how many parameters have been defined. The question mark character is used to denote an optional parameter. The optional parameter operator has been applied to the val parameter, which means that the function can be invoked with 0 or 1 argument. Within the function, the parameter type is string or undefined, because the value will be undefined if the function is invoked without an argument. Parameters can be defined with a default value, which will be used when the function is invoked without a corresponding argument. This can be a useful way to avoid dealing with undefined values. The default value will be used when the function is invoked without an argument. This means that the type of the parameter in the example will always be a string, so I don't have to check for undefined values. REST parameters are used to capture any additional arguments when a function is invoked with additional arguments. In the example, the REST parameter must be the last parameter defined by the function, and its name is prefixed with an ellipsis. The REST parameter is an array to which any extra arguments will be assigned. In the example, the function prints out each extra argument to the console, and that produces the following result. You can return results from functions by declaring the return data type and using the return keyword within the function body. In this example, the new function defines one parameter, which is a string, and returns a result, which is also a string. The type of the result is defined using a type annotation after the parameters. TypeScript will check the use of the return keyword to ensure that the function returns a result and that the result is of the expected type. JavaScript functions are values, which means you can use one function as the argument to another, as demonstrated here. The writeCity function defines a parameter called f, which is a function that it invokes to get the value to insert into the string that it writes out. TypeScript requires the function parameter to be described so that the types of its parameters and results are declared. This is the arrow syntax, also known as fat arrow syntax or the lambda expression syntax. There are three parts to an arrow function: the input parameters surrounded by parentheses, then an equal sign and a greater than sign, and finally the function result. The parameter function doesn't define any parameters, so the parentheses are empty. This means that the type of the parameter f is a function that accepts no parameters and returns a string result. The parameter function is invoked within a template string. Here only functions with the specified combination of parameters and result can be used as an argument to writeCity. The getUK function has the correct characteristics. Notice that only the name of the function is used as the argument. If you follow the function name with parentheses, then you are telling JavaScript to invoke the getUK function and pass the result to the writeCity function. TypeScript will detect that the result from the getUK function does not match the parameter type defined by the writeCity function and will produce an error when the code is compiled. The arrow syntax can also be used to define functions, not just to describe them, and this is a useful way to define functions inline. This inline function receives no parameters and returns the literal string value Paris, allowing me to define a function that can be used as an argument to the writeCity function. Functions can access values that are defined in the surrounding code using a feature called closure. In this example, the new arrow function returns the value of the variable named myCity, which is defined in the surrounding code. This is a powerful feature that means you don't have to define parameters on functions to pass around data values. But caution is required because it is easy to get unexpected results when using common variable names like counter or index, where you may not realize that you are reusing a variable name from the surrounding code. JavaScript arrays works like arrays in most other programming languages. So here I have created a new and empty array using the literal syntax, which uses square brackets and assigned the array to a variable named myArray. In the subsequent statements, I assign values to various index positions in the array. There are a couple of things to note in this example. First, I did not need to declare the number of items in the array when I created it. JavaScript arrays will resize themselves to hold any number of items. The second point is that I did not have to declare the data types that the array will hold. Any JavaScript array can hold any mix of data types. In the example, I have assigned 3 items to the array: a number, a string, and a boolean. The TypeScript compiler infers the type of the array as any, denoting any array that can hold values of all types. In this example, arrays can be restricted to hold values of specific types, as showing in this example. Type union restricts the array so that it can hold only number, string and boolean values. Notice that I have put the type union in parentheses because the union number or string or boolean denotes a value that can be assigned a number, a string or an array of boolean values, which is not what is intended. So array can be defined and populated in a single statement. If you omit the type annotation, TypeScript will infer the array type from the values used to populate the array. You should rely on this feature with caution for arrays that are intended to hold multiple types because it requires that the full range of types is used when creating the array. You read the value at a given index using square braces, placing the index you require between the braces. In this example, the TypeScript compiler infers the type of values in the array so that the type of the val variable is number, string or boolean. You can modify the data held in any position in a JavaScript array simply by assigning a new value to the index. The TypeScript compiler will check that the type of the value you assign matches the array element type. In this example, I have assigned a string to position 0 in the array, a position that was previously held by a number. And this code produces the following output. You enumerate the content of an array using a for loop or using the for each method, which receives a function that is called to process each element in the array. The JavaScript for loop works just the same way as loops in many other languages. You determine how many elements there are in the array using its length property. The function passed to the for each method is given two arguments: the value of the current item to be processed and the position of that item in the array. In this example, I have used an arrow function as the argument to the for each method, which is a kind of use for which they excel. The spread operator is used to expand an array so that its contents can be used as function arguments or combined with other arrays. In this example, I use the spread operator to expand an array so that its items can be combined into another array. The spread operator is an ellipsis and it causes the array to be unpacked. Using the spread operator, I can specify my array as an item when I define the other array, with the result that the contents of the first array will be unpacked and added as items to the second array. And this example produces the following results. JavaScript arrays define a number of methods, and the most useful of which are described here. Since many of the methods in this table return a new array, these methods can be chained together to process a filtered data array. I use the filter method to select the number in the array and use the reduce method to determine the total, producing the following output in the browser's JavaScript console. Notice that I have had to give the TypeScript compiler some help with the type annotation and the as keyword. The compiler is sophisticated but does not always correctly infer the types in this type of operation. JavaScript objects are a collection of properties, each of which has a name and value. The simplest way to create an object is to use the literal syntax. The literal syntax uses braces to contain a list of property names and values. Names are separated from their values with colons and from the other properties with commas. Two objects are defined here and assigned to variables named hat and boots. The properties defined by the object can be accessed through the variable name, as shown in this statement. When the TypeScript encounters a literal object, it infers a type using the combination of property names and the values to which they are assigned. This combination can be used in type annotations, allowing the shape of objects to be described as, for example, function parameters. The type annotation specifies that the product parameter can accept objects that define a string property called name and a number property named price. A type annotation that describes a combination of property names and types just set out a minimum threshold for objects, which can be defined additional properties and still be conformed to the type, as shown in this example. Here the listing adds a new property to the objects assigned to the boots variable. But since the object defines the properties described in the type annotation, this object can still be used as an argument to the print details function. A question mark can be used to denote an optional property, allowing objects that don't define the property to still conform to the type. The type annotation adds an optional category property, which is marked as optional. This means that the type of the property is a string or undefined, and the function can test to see if a category value has been provided using the language features described here. This code produces the following output. Classes are templates used to create objects, providing an alternative to the literal syntax. Support for classes is a recent addition to the JavaScript specification and is intended to make working with JavaScript more consistent with other mainstream programming languages. JavaScript classes will be familiar if you have used another mainstream language such as Java or C#. The class keyword is used to declare a class, followed by the name of the class, which is product in this example. The constructor function is invoked when a new object is created using the class, and it provides an opportunity to receive data values and do any initial setup that the class requires. In this example, the constructor defines name, price, and category parameters that are used to assign values to properties defined with the same names. The new keyword is used to create an object from a class. This statement creates a new object using the product class as its template. Product is used as a function in this situation, and the arguments passed to it will be received by the constructor function defined by the class. The results of this expression is a new object that is assigned to a variable called hat. Notice that the objects created from the class can still be used as arguments to the print details function. Introducing a class has changed the way that objects are created, but those objects have the same combination of property names and types and still match the type annotation for the function parameters. I can simplify the code in the example by moving the functionality defined by the print details function into a method defined by the product class. Methods are invoked through the object like this. Here the method accesses the properties defined by the object through the this keyword. And here is an example that produces the following output. TypeScript provides support for access controls using the public, private, and protected keywords. The public class gives unrestricted access to the properties and methods defined by a class, meaning they can be accessed by any other part of the application. The private keyword restricts the access to features, so they can be accessed only within the class that defines them. The protected keyword restricts access so that features can be accessed within the class or a subclass. By default, the features defined by a class are accessible by any part of the application, as though the public keyword has been applied. You won't see the access control keywords applied to methods and properties because access controls are not essential in an Angular application. In this example, I'm simplifying the class in the main.ts file. Here I'm adding one of the access control keywords to a constructor parameter has the effect of creating a property with the same name, type, and access level. So, adding the public keyword to the price parameter, for example, creates a public property named price, which can be assigned number values. The value received through the constructor is used to initialize the property. This is a useful feature that eliminates the need to copy parameter values to initialize properties, and it is a feature that I wish other languages would adopt. Classes can inherit behavior from other classes using the extends keyword. The extends keyword is used to declare the class that will be inherited from, known as the superclass or base class. In the listing, discount product inherits from product. The super keyword is used to invoke the superclass's constructor and methods. The discount product builds on the product functionality to add support for a price reduction, producing the following results. When applied to an object, the type of function will return object. To determine whether an object has been derived from a class, the instance of keyword can be used. The instance of keyword is used with an object value and a class, and the expression returns true if the object was created from the class or a superclass. JavaScript modules are used to manage the dependencies in a web application, which means you don't need to manage a large set of individual code files to ensure that the browser downloads all the code for the application. Instead, during the compilation process, all of the JavaScript files that the application requires are combined into a larger file known as bundle. And it is this that is downloaded by the browser. Each TypeScript or JavaScript file that you add to a project is treated as a module. To demonstrate, I created a folder called modules in the src folder. Added to it a file called nameandweather.ts. The classes, functions, and variables defined in a JavaScript or TypeScript file can be accessed only within the file by default. The export keyword is used to make features accessible outside of the file so that they can be used by other parts of the application. In the example, I have applied the export keyword to the name and weather location classes, which means They are available to be used outside of the module. Here I have defined two classes in the name and weather.ts file, which has the effect of creating a module that contains two classes. The convention in Angular application is to put each class into its own file, which means that each class is defined in its own module. The import keyword is used to declare a dependency on the features that a module provides. In the example, I have used the name and weather location classes in the main.ts file, and that means I have to use the import keyword to declare a dependency on them and the module they come from. In this example, this is the way that I use the import keyword in most of the examples. The keyword is followed by curly braces that contain a comma-separated list of the features that the code in the current files depends on, followed by the from keyword, followed by the module name. And in this case, I have imported the name and weather location classes from the name and weather module in the modules folder. Notice that the file extension is not included when specifying the module. When the main.ts file is compiled, the Angular development tools detect the dependency on the code in the name and weather.ts file. This dependency ensures that the name and weather location classes are included in the JavaScript bundle file, and you will see the following output in the browser's JavaScript console, showing that code in the module was used to produce the result. Notice that I did not have to include the name and weather.ts file in a list of files to be sent to the browser. Just using the import keyword is enough to declare the dependency and ensure that the code required by the application is included in the JavaScript file sent to the browser. You will see two different ways of specifying modules in the import statements. The first is a relative module, in which the name of the module is prefixed with dot and /. This statement specifies a module located relative to the file that contains the import statement. In this case, the name and weather.ts file is in the modules directory, which is in the same directory as the main.ts file. The other type of import is non-relative. The module in this import statement does not start with dot and /, and the build tools resolve the dependency while looking for a package in the node modules folder. In this case, the dependency is on a feature provided by the @angular /core package, which is added to the project when it is created by the ng-new command. Angular relies on a package named RxJS, also known as Reactive Extensions or ReactiveX. The Reactive Extensions library is useful in Angular applications because it provides a simple and unambiguous system for sending and receiving notifications. It does not sound like a huge achievement, but it underpins most of the built-in Angular functionality, which needs to change the HTML content displayed to the user when the state of the application changes. You won't often need to work with RxJS directly, but there are some features described in this course that rely on RxJS, and a basic knowledge of the building blocks RxJS provides can be useful. The key reactive extensions building block is an observable, which represents an observable sequence of events that occur over a period of time. This is most often encountered when using the Angular support for making HTTP requests, where the outcome of the request is presented through an observable T object. The generic type argument T denotes the type of event that the observable produces, so that an observable string will produce a series of string values. For example, an object can subscribe to an observable and receive a notification each time an event occurs, allowing it to respond only when the event has been observed. In the case of an HTTP request, for example, the use of the observable allows the response to be handled when it arrives, without the handler code needing to periodically check whether the request has completed. So if you are familiar with JavaScript, you may wonder if an observable is the same as a promise, which is the typical way of dealing with asynchronous operations. The key difference is that an observable represents a series of events rather than a single result, which better suits the way the Angular works. HTTP requests can be handled equally well with an observable or a promise, but the other Angular features require ongoing notifications, which is where RxJS excels. The basic method provided by an observable is subscribe, which accepts an object whose property are set to functions that respond to the sequence of events. The property names and the purpose of the functions are described in this table. If you only need to specify a function that receives events, then you can pass that function as the argument to the subscribe method. This example defines a function that receives an observable string and writes out the sequence of string values that are received. The RxJS package is added to the project when it is created. The receiveEvents function defines an observable string parameter and calls the subscribe method, providing functions that write out messages when an event is received and when the event sequence ends. The reactive extensions observer T class provides a mechanism by which updates are created, using the methods as described in this table. This example defines a function that receives an observer string and uses it to send a series of events before calling the complete method. The reactive extensions library provides the subject T class, which implements both the observer and observable functionality. A subject is useful when you are working with RxJS in your own code, rather than using an observer or observable provided through the Angular API. Here I have created a subject string and used it as the argument to invoke the functions defined in the previous sections. This example uses the subject class, which is the simplest way to create an object that is both an observer and an observable. Its main limitation is that when a new subscriber is created using the subscribe method, it won't receive an event until the next time this next method is called. This can be unhelpful if you are creating instances of components or directives dynamically and you want them to have some context data as soon as they are created. The reactive extensions library includes some specialized implementations of the subject class that can be used to work around this problem. The behavior subject class keeps track of the last event it processed and sends it to the new subscribers as soon as they call the subscribe method. The replace subject class does something similar, except that it keeps track of all of its events and sends them all to new subscribers, allowing them to catch up with any events that were sent before they subscribed.